Hey everyone, welcome. We'll start a little bit early. We've got a good quorum here of folks joining us for our meetup. Hi everybody, my name is Mark Brown. I'm a program manager on the Cosmos DB team. Welcome to our global Azure Cosmos DB user group for our monthly meetup. I guess the first one of the new year, which is great. So been a couple of months since our last one. Got Hasan Savran with us this month. How are you doing?
Great. Thank you. Thank you for having me today.
Yeah, great. Well, welcome. And this month you're going to talk about performance tuning for Cosmos DB. I saw you tweeted out some new tool you created. This is all part of kind of what you're going to show us today? Is something kind of cool you created in VS Code or for VS Code?
Yeah, I created a VS Code extension for the Cosmos DB because I'm kind of like tired of, I guess, querying by using the web applications. So I want to have like something more like, I guess, solid. When I press F5, it's not going to refresh the page. So I was like,
Are you
well, I
saying
will
you
do it
don't like
myself.
parsing the diagnostic string that we send back and the response object? Is that what you're saying?
Nah,
Kind of
no, no.
subtly.
No, but I'm not trying to create my own in the meantime, and I'm creating it when I'm thinking about like what I'm gonna speak. Actually, I can make the tool a little bit better, so actually people might understand what's happening in the back end much easier. So I think I will kind of demo that in here too. So I think it will kind of help people to understand really how things working in the back end, especially if you are
All
coming from
right.
the
Well,
SQL Server or something. It can be sometimes challenging.
yeah, right. I think with anything in Cosmos, it's critical to measure what you're doing so that you can understand kind of the profile of what you've built and designed in there. I mean, with any kind of managed or resource governed service, understanding kind of the cost of things, latency, all those things, whatever, all matters, so that you can kind of better understand the characteristics of your workload. So, very cool. Uh, well, we're going to try again this month with some giveaways. So I'll do a drawing at the end of this thing. So if you make a comment in here, ask a question, etc., you get entered into the drawing. We'll do two. And for our lucky winners, they will get a Cosmos DB sticker. I don't know if that's really rendering very well. I'll try it again. You get a sticker, and then you will also get one of these very cool Azure Cosmos DB neoprene drink coasters that you can put on your desk. And everybody that walks by your desk, which is probably your wife and kids or your father, husband and kids, given that we're all working from home, get to see how much you love Cosmos DB. So that's that for announcements, and feel free to ask questions during the meetup. I can just interrupt you, I guess, Hasan, or
Sure.
um,
Yeah.
during our time here. Okay.
Sure. Yeah. I'm,
Well,
I'm sure you can answer some of them too. So some of the questions you might even know better than me. So
I don't know. I'm getting old, so I forget. I forget stuff now. All right, sir. It's all yours. Take it away.
All right. Thank you. Thank you, everyone, for joining me today. And I'm going to try to, I guess, talk about some how you can maybe keep your Cosmos DB solution scalable and affordable in this talk. So we are going to look at the physical partitions first. Then I'm going to try to talk about how, I guess, you can change your connection types to Cosmos DB. We will talk about caching. It can actually save you a good amount of money if you have a case for it, case to use it. And there are some .NET and SDK options that you can actually change and kind of play with, and it might, like help you with your applications. And at the end, we will talk about the indexing policies and how they can actually help you with your mostly request units. So let me, I guess, speak about myself a little bit. My name is Hasan Savran, and I'm a Microsoft Data Platform MVP. This is my third year. I'm proud and happy to have that. I'm from Cleveland, Ohio, and I have been doing web development 15 plus years, and I have been doing business intelligence, I guess, job for last almost 9 years now. Uh, check out my blog. I like to mostly write in Cosmos DB, but you can find the SQL Server, C# front end, whatever I kind of know, I share it out there. So check it out. You might find something interesting out there. And if you will have any questions that I may not answer here, please you can reach me from the LinkedIn or the Twitter. I will be more than happy to help you with any of your questions. So let's start with physical partitions. When it comes to the physical partitions in Cosmos DB, really you don't have that much, I guess, settings to play with because mostly it's managed by Microsoft. So you really cannot do anything. But there are some information here that you should know by your heart about the physical partitions if you are using the Cosmos DB. The first thing you need to know, there is a replica set in each physical partition. So you have a one leader and 3 followers. Also, this is the place where actually Cosmos DB stays. So that's where all the query engine, storage engine, indexing engine, everything is Cosmos DB is installed right here. There are 2 numbers here that you should know by heart, and those are the limits of each physical partition. The first one is the storage limit, and that is 50 gig. So that means if you're going to have more than 50 gig physical, you're going to have another physical partition. Also, each physical partition can give you up to 10,000 request units. So you might not have 50 gig data, but you might have a very heavy traffic application, and you might need maybe 15,000 request units. That means you're going to end up with 2 physical partitions. And the model you see here is for global distribution. Without global distribution. If you are going to have a global distribution, this model that you see is going to change a little bit. One of the followers are going to turn into the forwarder. So that forwarder is going to actually take the data coming from the leader and send to other leaders. So all the data will sync in the backend. Now, let's actually look at an example for the physical partitions. Let's say you have a database with 180 gig data in it. That's, let's say, one container. That means you're going to have 4 physical partitions. It doesn't have to be just 180. Maybe you don't have that much data, but you need 35,000 request units, 35,000 request units. In that case, you end up with 4 physical partitions again. Now, I guess the first thing to kind of remember here is you might have an application and you might not need that much request units. Maybe 5,000-6,000 is going to be enough for you at the beginning, right? But you might need to push some data, you might need to do some bulk loads, and you might want to just, maybe put 10,000-20,000 request units to actually save your data. And you might just think that, okay, after that, I will back to 8,000 request units. That will work. But the problem is, for example, if you turn to 35,000 request units, you end up with 4 physical partitions. And don't think that when you actually put it back, scale down to 8,000, you're going to end up with 1 physical partition. That's not going to happen. So you're going to have 4 physical partitions, and Cosmos DB is not going to merge that data back to you if you are going to scale down your applications. Now, let's say we are maybe saving, orders, right? So we are getting all kind of orders, and we are saving orders in this container. Now, we have the application, and the application is try to get some kind of orders. You're going to run a query. Maybe you're going to say, okay, give me the orders in this country, right? Now, right now we have 4 different locations to get the data. How application is going to know where the data is, right? This is not a SQL server. You have only one place. The data is centralized, and it's going to go exactly where to get the data. We have 4 different locations to get the data that application is looking for. That's where actually Mr. Partition key comes up. So if you actually put the right partition key here, in our case, we are looking, for example, by country. Well, if our partition key is the country code, let's say, then application is not going to know exactly which physical partition it should go and get the data. If you are running this one for different rather than country, maybe you can say that give me all the orders. I don't know, the cost is or the price is larger than $1,000. Well, Now application has absolutely no idea where to go. It needs to go in each physical partition and run this query, which will, fine, it will do it. But the problem is then you are going to run the CPU, you are going to run the memory in each of those computers. Then your request units is going to be much higher. So you kind of need to know partition key if you want to kind of get, I guess, hit the right place and get the right data. Now, I think this is a good place to actually show my extension, VS Code extension to you. And I think that I will try to explain that a little bit here by using the extension. You can get this extension for free. It is a Visual Studio, and I call that Cosmos DB SQL Studio. It's just support the SQL API for now. That's why I call it SQL Studio. And I may change it later if I will actually support other APIs, I guess. So there are two ways to connect your Cosmos DB. The first one, you kind of need to be, I guess, the owner of the subscription. And it will take longer because it will try to kind of find all the subscriptions, all the database accounts and other stuff. The easiest is really the connection string. So let me get my connection string here and paste right here. And then it should kind of go and find all my databases and containers. So the first I'm going to look at, I put the Stack Overflow data and just put in one of my databases here. So this is my database and this is my container. Now I'm going to run very simple, I guess, query here. So I'm going to say, give me top 10, everything from hosts. When I execute this, you are going to see that this cost 2.62 request units. That's pretty good. I don't think you can make this better, right? And I'm getting 10 items. So if you actually want to see the execution metrics here, it's going to show you all the execution metrics. The important part here is we are hitting one physical partition. So this container is not really that large, and I don't need to worry about different, partitions. So always, I'm going to deal with one physical partition. So my queries are going to be much cheaper because I don't have to worry about other physical partitions. Now, let's change this. Rather than, let's see this bigger one. This big, actually it has more data. So I'm going to actually run the same one. But this time, I am not going to deal with one physical partition. I'm going to deal with more. I'm still running the top 10 here. And the only difference is I have different physical partitions. Well, look at my request charge. Now it's 13.11. It used to be 2.62, I think. I'm running the same query, but as you can see, I am actually hitting 5 physical partitions. So I am running this query in 5 places. When you click on it, you will see in each physical partition, it runs this query, and it tells you how much actually it cost you. So really, I want top 10, but I'm getting 50 because, well, it gets top 10 from each physical partition. So if you are going to run your queries, cross partition like that, and if you are having this issue in the application, there's not that much you can do to fix this problem. You kind of need to use the partition key, right partition key, to actually fix the problem. And you might need to, change your partition key to fix problem if you are having issues like this. So let's look at one more thing here. Let me actually go back my older one, smaller one. So I am going to run this again. And I'm hitting the number one here. The number one partition is 1. So everything is good, 2.62, right? So let's try to actually increase this a little bit. Let's go, for example, make 90. Let's see what's going to happen. So with 90, it go up to 5.61. Okay, I understand that because I'm getting more data, right? So let's go a little bit more. 99. We have 5.92. What if actually I'm going to go here 101? That's just like adding 2 more items. Now, well, actually, that's a big increase, right? I wonder what happened out there because it was just, the small digit number were changing. Now, actually, we had a big change here. What actually happened here is Cosmos DB has this option in the backend. call max item count. So what's really happening here is every time you request data from Cosmos DB, it gives you data 100 packages. So it sends you 100 first, and it gives you a token name continuation token. You take that continuation token and you actually run the query again, and Cosmos DB gives you the rest of the data back to you until the data is done. In my case, I am actually hitting the Cosmos DB twice here. That's why this number jumped from 5 to 8 quickly like that. So really, if I go like this, for example, select top 100 from C and select top 1 from C. If I run this one, probably this is going to be, let's say, 5 something, 595. And if I go this one, it's going to be 2 something. Probably if you're going to put the 595 plus 2.27, that's what you're going to get here. So really what's happening here is we are hitting the Cosmos DB twice. So potentially you can overwrite this, and let's say rather than 100, I say 150. Now, I do this and run this again. As you can see, 8.22 executed. Now it's 598. I didn't change that much. The only thing I really changed is one of the headers that Cosmos DB has, max item count. And by just doing that, I did a good kind of, I kind of save request charge here.
Hey,
so
Hasan, I got a question from viewer here, Dr. Greg, regarding that top part, that cross-partition query where you were grabbing 10 from each of the partitions. I suggested change how the top was being defined with an order by, or could you? Otherwise, it has to get from 10 each and doesn't know any particular which one will return the 10.
So if you know the partition key, we can actually make that better. So if I go, for example, here, run the execution, actually, let's change the database to a bigger one first. And let's run this again. So it looks like, see, when I change the container, it tells you what your partition key. So post ID is the partition key. So when I run this, it's 5 views. And when I go here and say that C post ID is, let's see what this is, 13486. This should hit only one partition key, as you can see, because we are defining the, the which partition we want to hit here. Then it goes exactly this right partition, and we don't have to run that.
I think what's being suggested is if you put an order by in there, it would somehow prevent the query from returning 10 from each of the partitions, which doesn't happen.
Yeah.
It's going to still issue each of those queries independently, and then when it gets back to the SDK, it's then going to merge and do a top on that, right? So
correct. Yeah. So what you're going to actually do here is if I get rid of this and run this AR again, so really you are going to order by, your query is still going to run in each partition with the order by in it.
It's even going to run even if there's no documents there, right? Like that's the other thing. It's not going to, there's not much in terms of RU cost. It's only really if it finds data, but it's still going to run and still going to cost, I don't know, at least a handful of RU just to go look at an empty partition. So
that's correct.
Yeah.
And the other thing, let me go back to my other container here. And so the other thing you can do here is, so let me actually run. Let's say we want to select everything, and we want to go, we know the, let's say we know the post ID, which is our physical partition, right? And that is in here 10.61.7. And on top of that, we know the ID. So we really know where this data is. So if that is the case, let's see what our ID here is. Let's copy and paste it right here. In that case, I really know exactly where my data is, but I'm still running a query. So if I execute this one, this is still going to be 289. Maybe it didn't like something here. 1 minute. Let's try something else. 685. And this is my ID. Let's try that. As you can see now, I'm getting one item, exactly what I'm looking for. Request charge is still, it's almost like 3. So if you are, using these cases, you can always use the, the point read for the Cosmos DB. So in this case, if I go and actually do this here, 9685, and pass my ID here, and you can do this only by the SDK, by the way. So if I run this, my request charge is going to drop to 1. So if you know exactly what your partition key and your ID is, you should use the point read rather than the query, because query is going to always cost you, much more than the point read.
Hey, other question from Greg here. So what if you did the order by on the partition key? Would it then limit to just a single partition to go grab the data?
Well,
Want
let's
to try that?
Sure. Let's
see
try it. So I'm going to go order by C post ID. All right, I still hit the 5.
Yeah.
And actually it's much higher now. It used to be 2 before, so now it's 3.
Actually, I wonder if maybe you need a composite index on that thing. So
yeah, I myself.
But they're different, right? So that's the thing, is the partition key is not
yeah.
It's not the index within the ID or the index within there. So yeah, it's always
I mean, what this one kind of shows me is I'm still not specifying the.
You need the filter predicate to really do the correct routing.
That's right.
Yeah.
Yeah. So I'm still hitting the 5 of them because I'm not really telling Go exactly this partition key.
Yeah. That's an interesting suggestion, though, Greg. It's actually something that we possibly could implement in the query parsing engine, is being a little smarter about that, because we know partition key range values behind the scenes. So that's possible, I think. So yeah, thanks for suggesting.
Yeah, thank you. So I mean, I think the last one I was just talking here was the max item count. And as you can see, by just changing the max item count to the different number here. So if you're always getting like, 100, 110, 120, if you actually upgrade this to 150 or 200, you might be actually saving some request charges per that query, if you like. All right, so let's go back to my presentation. I hope that made a little bit more, I guess, clear how the physical partitions works in the backend and how important is actually the partition key here. Without picking the right partition key, really, I mean, every other solution we are going to give you is going to be a band-aid. The problem is going to get larger and larger. As you can see, we have 5 partitions here. If you have 10 partitions, then you are really kind of, I guess, doubling that request charge. So you kind of need to pick the right partition key for sure. All right, next is really the Cosmos DB is just like the vending machine, right? You kind of need to exactly know what you want, and you kind of organize Cosmos DB like that. In the right side here, as you can see, those are the bin stores. I don't know if you ever been. I like them. And you go and try to find whatever they have. Do not try to store your data like that, right? Because my select top 10 is going just like that. I'm just telling the Cosmos DB, go and run the select top 10 in each bins. So Cosmos DB is going to use more resources, and it's going to cost me more, because then, probably you're going to say that, oh, Cosmos DB is expensive. It's not really expensive. It's just you are really forcing it to work hard. And if you actually organize the data just like the left side here, the things are going to go, work much smoother. All right, I think this is good for physical partitions. Let's go to the connections. So there are different ways to connect Cosmos DB. The first one is the gateway that I'm going to speak here. This one is the default mode for the SDK2. And what's really happening here is there is a server between you and the Cosmos DB called Gateway. And that server is getting actually shared by other Cosmos DB customers. So what's really happening here is you have, or that can be two different customers. One of them is using Mongo API, other one's using SQL API. They call the gateway, and gateway is doing some kind of interoperability out there. So it kind of changes the language a little bit and calls the Cosmos DB and gets the data and returns back to you. Why do you want to do this, right? The main reason you want to do that, maybe you have some, strict firewall restrictions, or you might have a limited number of socket connections. So then really this way is going to be much easier for you because gateway uses the HTTPS and REST. So it's pretty common and you shouldn't have any kind of security problems or, like the socket problems because of that. So that kind of really is good for that. In the meantime, when you use that, you are adding one more, network hop because, well, we are connecting the gateway first, then, gateway gets the data and returns back to you. So that's, I guess, the trade-off out there. Also, as I said before, you don't own that gateway server, so you are sharing it with other customers. What you can do to actually improve, I guess, the performance here? The only thing really you can do here is because you are dealing with the HTTPS, you have like a limit, a number of connections limit, and the current limit is 50. So if you want a higher concurrent connections to Cosmos DB, actually you can change to 50 to different number here, and it's under the max connection limit, connection policy, max connection limit, and they can pick anything from 100 to 1000. So by just doing that, you are really adding or changing the concurrent numbers that Cosmos DB connections. So you can try that. As I said before, this is for SDK2. For SDK3, actually this change for SDK3 in SDK3 is direct connection. So direct connection is using the TCP. And that kind of pushes more, I guess, work to SDK because now SDK is the one which is going to figure out where the physical partitions are. And if you're an SDK2, you can still use the direct connection if you like. As you can see in the left bottom corner here, you can kind of specify you want to use direct whenever you are initializing the Cosmos client. And this is available only in .NET and Java SDK for now. And this offers better performance because you don't really have anything in the middle anymore. So middleman is gone, and you are actually calling Cosmos DB directly here. And this is probably, I guess, the best way to call Cosmos DB, fastest way. Third one is a new one, and this one is in public preview right now. This is called dedicated gateway mode. And really, this is the gateway mode, but this time you actually own the gateway server. Since you own the gateway server, it's not free. You kind of need to, pay for it. Here are the current prices for it, and they might change when this one goes to GA, but this is the current numbers for now. So to make this work, you actually go and pick one of those options here and create the gateway, dedicated gateway server. Then you will actually see a different connection key for the gateway server that you created, and you can use that to actually make the calls, and by using this dedicated gateway server. This is available only in the SQL API, and one important thing, you cannot change. For example, if you pick, let's say, the D8s, you cannot change that later. You can add and remove more, but you cannot change your options. So just, I guess, whenever you are picking it, just pick it wisely. So what is actually giving to us, right? So what, by paying this much money, why is this important? Well, it's important because actually Cosmos DB did something really interesting here. So what's really happening here is they gave us caching functionality. So for caching to work, we have our server and we are calling, we are reading or querying the data. So we go to our dedicated gateway server, gets the data from the database and returns it. That costs us, let's say, 5 request units. Next, if we are going to make the same read or the same query, now our gateway server is not going to go to Cosmos DB anymore because it knows that we already got this, and that's going to cost us 0 request units. So all this functionality here is actually living in the dedicated gateway server. Now, that is important because Cosmos DB team was able to give that functionality to us by not changing anything in the DBA engine. Maybe they did change since I'm not in the Cosmos DB team, but it really doesn't make sense to change anything in something working fine, right? So they were actually able to do something like that in different location in this gateway server. And the caching is actually working in the gateway server, and they don't have to kind of add anything here in the database engine. You know, whenever you change something in production, you might potentially introduce bugs. So if something is working fine, right, don't touch it. So that kind of works fine here. And what's going to really happen here is if you are doing like a lot of lookups, if the data always you are getting the same data, this might save you a good amount of money. So you might need to kind of look at your queries. If you're kind of reading the same data again and again, it might make actually sense to buy one of those dedicated gateway servers and put the caching on it. Then everything might cost less for you. For that thing to work, your consistency level must be eventual, and this might change whenever this becomes available later in GA. But for now, it has to be eventual consistency level. So to make this actually work, first, as I said before, you have to go and get your dedicated gateway from this link here. After you when gateway server comes online, you can go back to keys and you will see that there are two different connection strings for you. You can pick one of them, and then you're going to put that in the connection string on your application. Your SDK must be 3.21 or later for this thing to work. So here actually how it works in the code. So I want to be sure that I am using the gateway connection mode here first. Then what I'm doing here is in my request options. First, I want to be sure that this request is going to be in eventual. I'm sure you don't want to change your containers consistency level to eventual. So you can only change the requests in this case. And also, optionally, you can tell to Cosmos DB how long this should be cached. So in my case, I am caching this for 30 minutes. So here's my query. I'm going to get all the post IDs, post ID smaller than 500. Now, if I run this, the first you are going to see that I have 592 posts, and it cost me 32.25 request units. When I run the same query again, well, guess what? It doesn't cost me anything anymore. So potentially that can help you a lot. You just want to be sure that you are reading the same data again and again, and it might really make sense to actually buy a dedicated gateway server and use the caching functionality on it. Next, there are some other tips and tricks that you can actually do if you are using the .NET. So, for example, for .NET, you want to be sure that you are using the 64-bit Windows host processing. Don't keep it in any CPU or any 32-bit. The main reason for that is in the 64-bit, we have this service interrupt.dll. This DLL is available only in the 64-bit, and it helps you to parse and optimize your queries locally. So you don't have to call the Cosmos DB for that. So you are really saving one request for each queries. So if you're in .NET, just be sure that you are using the 64-bit Windows host processing. Second one is the garbage collection. In garbage collection, there are two types of garbage collections, and one of them is the workstation, the other one is the server mode. Most of us is using the workstation, especially if you are debugging or if you have only one CPU or two CPUs on your computer. But if you are pushing this on server, it really makes sense to actually turn on the server mode on. And to make that happen, actually, you can do this in the .NET Core, just system.gc server true. So this will be sure that you are using the server mode in the application on your server. Third one, if you are testing your application and if you're actually hitting if you need large request unit to test the application, and if you are hitting like 50,000, your CPU is gonna become the bottleneck here, because it's not gonna able to, I guess, handle all the requests and responses in the same time. So if you are actually getting close, I would say even 40,000, you might want to add another workstation. So you might not just test from one computer, but you might just want to kind of, I guess, share that to two computers, because Cosmos DB can handle it, but I'm not sure if your application on just one CPU is going to be able to handle that much requests if you are testing, special stress testing the application. All right. Next is the Stream API. Stream API became available in SDK 3, and it's really getting rid of that serialization and deserialization that SDK 2 uses. So in SDK 2, you pull the data from database, you serialize the data, and you make a document. I don't know, let's call order, right? We make an order. Then, well, you have to pass that order to the client. Then you deserialization and move it to JSON. So that's how everything works. In SDK 3, you can actually pull the data from the Cosmos DB and give the client the JSON document directly, without converting the object to order, product, user, whatever. So you can just send it directly. So let's see how this actually works. So this is the SDK first 2x. If we want to do serialization, really, as you can see, what's happening here is we have the sales. So sales is the document. Every time I'm getting the data from the Cosmos DB, I am actually adding the sale in my document. And when I'm done with this, I need to return the sales to my client, and it's going to be a JSON document. So that's going to be the deserialization. If you want to do that by SDK 3, then the first thing you need to know is SDK 3. To use this, you have to know which partition you are hitting. So you have to pass the partition key. You cannot run this with the cross partitions. The second, as you can see, I am creating my response here, and there is no, I guess, order or whatever document is. I am getting a stream and creating a JSON and directly loading the JSON and just sending back to client. So in this case, I don't need to worry about serialization and deserialization. If you know the partition key, this will actually save you and give you a better performance for sure. Next one is Singleton. Singleton is a creational design pattern, and idea is really that a class has only one instance while providing a global access point to this instance. So you want to define it once and use it multiple times. So this actually works great with document client, Cosmos DB. You want to define document client once, and you want to use it many times in the application. You don't need a different document client for different containers. One document client can access all of them in the same time. So you don't really need to define it many times. So if we look at, there are many ways to actually, define the singleton. So the option I'm giving you here is for .NET Core. I'm sure there are other ways for the different languages. So as you can see in the configure services, I am creating my singleton here. I'm just passing the document client. From here, I can actually use it in my controllers anywhere. So I don't need to define the document client in each container, container anymore, each controller anymore, sorry. And the other thing to kind of look at here is network credential. This actually creates a secure string, and really maybe you know it, but I didn't know that, so I just want to kind of look at that too. This is a secure string. So what's really happening here is it kind of keeps this information you are passing confidential, and if it doesn't need it, it just removes it from the memory. So in this way, if you define your passwords this way, it will be much safer, not just like Cosmos DB, but for any other kind of passwords or anything like that you are using. So I thought that was interesting. So so let's see why we don't want to define or initialize the client, Cosmos client, document client many times. So let's look at it. Every time you initialize document client, the first thing actually SDK does is it's gonna go and get your account information, because it kind of needs to know who you are, right? After that, it's going to go and make another request. And the guy's going to get all the containers you have. then it still needs to know the partitions where they are. So it's going to go and figure out where the partitions are. So you are really looking here like 3 requests already to figure out, where the data is, who you are, where the containers are. So now in this case, okay, we know who you are. We know this is your partitions. We are ready to use our document client. This is a good place to actually talk about the constant system mode. Constant system mode is going to actually define, okay, I know where the data is, but depending on the constant system mode, you might need to hit, for example, one follower here, or if it's strong, then you might need to actually hit multiple nodes here to be sure that you are getting the latest data. So depending the constant system mode, we are going to actually go and get the data from here. So this is why you don't want, to initialize your document client every time before you call the Cosmos DB, because all those steps has to be done. And if you do that from the Singleton in your configure services, it's going to do it once. It's going to cache everything there. Then you don't need to do this again and again. So that will save you time and performance for sure. Next one is optimizing the bandwidth. So I guess I'm showing the those tags. Whenever you buy shirts and other stuff, they might come with all kind of tags, and usually people just cuts them out, right? So we can use the same kind of the idea with the Cosmos DB. Every time you insert, you update, you delete, you send all the information to Cosmos DB, and Cosmos DB, when it actually returns back to you the the result, all that request is actually still in your response object. So for example, here we are trying to create a file or create a document or updating a document. The body of the item is going to the response is going to have our request in it. So really the response, I would say 90 to 95%, you don't probably need that. And by just removing the request from the response object, well, the package is going to be much smaller, and you're going to optimize the bandwidth, and probably it's going to be faster too, depending how many especially if you have a write heavy application. So you can do that in Cosmos DB, and to be able to do that, here for example, I am pushing some geospatial data here to my Hurricanes database, and I am doing some updates, and I'm saying, what, I don't want whatever I'm sending back to me in my response object. So to do that, we have the item request options, and I am saying enable content response on write is false. So that's going to actually force Cosmos DB to not send me back my request for my insert, update, and delete. So that will actually save you some bandwidth with that, and it will make the packages smaller, response packages coming back. Next one is one of the newest ones. This is a partial document update. And really before the partial document, what was happening here is if you want to, for example, update one property of a JSON document, and it can be maybe a flag, you want to just make it false from true, you still need to kind of, send the whole JSON document back to Cosmos DB, and Cosmos DB figures out what needs to get updated, and it updates. So really the request was pretty high. It can, let's say, your JSON document maybe 10 kilobytes. You need to send the 10 kilobytes data to actually update just one flag from true to false. By using the partial document, you don't have to send the whole JSON document anymore. So you can actually add, which is going to create a new elements. You can update them. You can delete an existing element, or you can increase or decrease the value of a number. If you want, you can combine them. So in this case, for example, I guess before the example, let me talk about this one too, because this one is kind of important too for the filters. You can actually attach a where clause in your update operation. So that where clause can actually control if it should get updated or not. So I think that was a good one too. I was just trying to play with it like last week. On top of that, it supports the transactions, and if you have global distribution, it supports the conflict resolution support too. So let's see how this actually works. The first one is just a simple partial update. As you can see, I am using partial add, and I'm doing a partial remove. So the first, I am adding this new property, sale date, and then I'm removing the another element from my JSON document. So you can have whatever you like here. If you want 5, 10 operations, you can send them together. And then I need to define what needs to get this patch operation. So this is my ID, this is my partition key, and those are the operations I'm passing. So really, in this case, rather than sending the whole JSON document, I am just sending two elements, and I'm just telling which JSON document should get those patch operations. The second one is the one I was talking about, the filter. So the first, what I'm doing here is I'm saying it's the same idea. So my patch operation is I am adding an audit element to my JSON document if the number of items is larger than 5. So if this ID is 20 is number of items larger than 5, then I'm going to add a new element, say audit, and I'm going to make it true. So this is going to actually make things a little bit interesting and nice. I like it, and I hope everybody's using it. If you don't know it, it's there. And also, that's not really gonna, I guess this is not gonna help you with any request units, because if you really think about it, Cosmos DB is doing the same exact thing. It still needs to open your JSON document, and it still needs to update whatever you're asking for it. So this is not really gonna save request units to you, but it's going to make, I guess, your life easier in the client side, so you don't have to send this chunk of JSON document to just.
Thanks for saying that, because there's just a question that came up there, right? So this patch is not going to save you throughput. We still got to merge the data on the back end. It does, however, save throughput if you fail concurrency checks and have to do a read again, right? So there's both cost of rereading the data and then latency involved with then merging it and then resending it back. So it can save our use. It's just the merge itself doesn't, or the update itself does not.
Yeah. Thank you for that.
Yeah. Thank you.
Mm-hmm. All right. So the next one is, I think it's pretty clear. Try to avoid blocking calls. Cosmos DB can handle all those calls together. So it's really in your end, if you can use the async code rather than the sync code. This can make things much faster, and that's what the Cosmos DB is really good for anyway. So try to use the async code as much as you can, rather than using the sync code like that. And if those each are the requests from Cosmos DB, you don't have to wait for 3 to be done, 2 to be done, 1 to be done, for 4 to happen. So if you actually send them together and use the async code, everything will work much faster in your application. All right, the next one is indexing policies. Now, we know Cosmos DB indexes everything, right? So when you say that to people, people might say that, oh yes, this is great, or they might say that, oh no. So it really depends, I guess, your kind of background, and if you are DBA and other stuff, you're gonna say that that might not be a good idea. And if you are dev, you're gonna say, oh, this is great because I don't need to worry about indexes anymore. So there are 3 types of indexing mode in Cosmos DB. It's recommended one is the consistent one, and lazy one is the most dangerous one, and we have another one for none. So if we look at how the actual indexing works, we had a file for data, and we have file for index or indexes, depending which database you are using. And whenever data comes in your data file, we want to be sure that whatever indexes you have is getting updated immediately. So because in many cases your queries are going to use the index file rather than the data file. So if your index file is up to date with data, then you're going to return the right data and right amount of data. So that's what actually the consistent does. So the consistency level is strong for consistent level. When data changes, it immediately changes the index file. If you are using lazy, that I recommend you to not use that at all. What you are really saying here is, well, your consistency level is eventual. So you are really saying is, okay, you know what, index file might not be matching my data file. So if the query is running the data from index file, well, you might have more data in the data file than index file, and you might not be returning all the data that you should. So lady is there, and if you are using it, I recommend you to just change it to consistent. Well, I will say immediately. The next one is the none. That means you don't need indexes. In what cases you might need that is maybe you are using the Cosmos DB as a key value, the database. If that is the case, your key is going to be partition key anyway, and probably value you might not. Probably it's going to be a JSON document or a large JSON document. You might not even need to index it anymore. Or maybe this is the first time you are just pushing data to Cosmos DB and there's a lot of data, then you don't really need to worry about the indexes, because hopefully when you are done with loading the data to Cosmos DB, you're going to go back and change your indexes anyway. So in that case, you will, from the none, you can make it consistent and change your indexes in that point. So those are the, I guess, the items I can really think of in how, if you want to use the none. And the other one is if you are going to use the none, that means that I believe time to leave requires you to use indexing mode. So for the none, you might not be able to use time to leave for that. Now, let's look at the index types. There are 3 types of index types in Cosmos DB. The most common one is the range index, which is whenever you use the equal to, larger from, or smaller from, that goes to the range index. That's the most common one. If you are using any geospatial data, we have geospatial data index, and the last one is the newest one is the composite index. Now, when you are using the index, there are many ways to, I guess, use the index file here. So from left to right, you always want to be kind of in the left side here. Index seek is the fastest you can actually use. And as you can see, whenever you use the equal to or in operator, you actually use the index seek. Full scan, that means that you are actually forcing Cosmos DB to greet every JSON document before it returns back data to you. So for example, if you are going to use the upper or lower system functions, then you are really going to force Cosmos DB to full scan. And full scan means, well, high request units. Also, as you can see, there are some other system functions that you might be using in your web class. It's kind of good to know which system function is using which type of index usage here. So because, for example, if you are using the contains here, and if you can do the same thing with the start with, you might actually be saving some request units. So it's kind of good to know which system functions are using how much which type of index usage. So you can actually find that in the Cosmos DB documentary, and those are some of them actually I add here. Also, I want to actually talk about a little bit more about the composite index, because it can really save you a good amount of request units. So, for example, you can use a composite index for multiple the properties. For example, you might be ordering by with multiple properties here, or you might be filtering and using the order by. So as you can see, this actually matches with the composite index. Or you might not have an order by, you just use the where clause with multiple the properties. So how this actually works here is, as you can see, you create your composite indexes in the indexing policy, and you are saying that this is the paths you want to create it, and it really creates almost like pointers. And in my case, I'm using the post ID, post date. You can go, I believe this up to 8, if I'm not making a mistake. You can add up to 8 properties here. And this will actually make your request units much lower if you actually hit the right ones. Order is important. And for example, if you are going to say order by in here, post by maybe descending, if it doesn't hit to the signature here, you might not, it will not use the composite index. So you want to be sure that orders are actually matching with your queries. So that actually takes us to, I guess, modifying indexes. This is what your indexing policy looks like when you open by default. As you can see, everything is included. That means you are indexing everything. Excluded is good if you want to, exclude any kind of information. So, for example, in my case, I was showing you the posts, and there is a post body out there which people kind of writes the questions, and probably you don't want to kind of, put an index on it because a chunk of string, and probably you are never gonna, I guess, use it to search data. So if that's the case, it's much easy for us to actually put this in here in the excluded paths. So in that case, my index file will be smaller, and my writes and updates will be much faster because I don't need to write that chunk of text to my index file every time I change data or I write data or insert data. And as I said before, do not use the lazy indexing mode. If you are using it, please just change it to consistent immediately. And if you have never heard about the composite indexes, I recommend you to kind of look at them, and they can really save you a good amount of request units. And also, whenever you are making an indexing change, do not try to change one by one. Try to make it in the same time, because as I said before, you are going to send this indexing to, depending how many partition key you have. You are not sending this just like one place. You are sending to many physical partition. It's going to take some time, and when your indexing changes, your index file gets truncated, and your queries are not going to be able to use the index file anymore. So probably your application is going to go down for that. So rather than changing indexing one by one, just come up with the plan and change all of them in the same time. All right, next one is the throughput, how we are going to actually use the Cosmos DB. There are three ways. The first one is the provision, and provision is the oldest one, and it's great for really for the production application, daily use application. It can support any kind of traffic. There's no damage limit on provisioned, and minimum you need at least 400 request units per second, and you can go as much as you like or you afford. And the second one is the auto scale. Auto scale is great if this is the first application you are writing is a new application, and you absolutely no idea how many people you're going to have using this application. And then what you can do here is you can pick a maximum request units, and then application, the Cosmos DB is going to actually scale up and scale down for you up to that number that you actually give. And if nobody's using it, it's going to scale down to, I think it's the 10%. That's the lowest of. So in my case here, I'm saying 4,000 requests is my high. The minimum is going to be the 10% of it. So this is great for unpredictable workloads or critical workloads. You want to be sure that it's always you're going to have enough request units to actually run the application. And also, this is great for dev and test environments. That happened to me many times. So I try to push some data. So my application might need only maybe 800 request units normally, but because I need to send a lot of data, I say, well, okay, I will just put 15,000 so my data load will be faster. And I forget it, right? And worst time it can happen is Friday, right? So if it happens Friday, you need to pay for Saturday, Sunday for really no reason. So in this case, if it's out of scale, when the data load is done, Cosmos DB can actually scale down for me, so I don't have to, I guess, pay for what I don't need. So auto scale is great for that. The third one is the serverless, and serverless is the newest one. And this is really great, again, for dev and tests and also proof of concept application. The serverless is the most, I guess, the limit one, because we have the 5,000 requests and 50 gig per container. So that's your limit. And that's really is the limited workloads. And if you have an application like infrequently, you don't know, especially this is good for the Azure functions. So if something is like you have the long idle times, light traffic, serverless might actually save you good amount of money because you are only paying for what you use. But in the meantime, it has limits that I say with the request units and the storage, and also there's no global distribution. So you have three options when it comes to the pick the throughput here, and also with the auto scale, I guess I will warn you. So let's say I want to say maximum is 50,000, but you know that you are never going to hit the 50,000 requests in this, right? I hear some stories that, well, sometimes people attacks to the websites like DDoS attacks and other stuff. So if that happens, well, it might hit the 50,000 and you might end up with a surprising bill. So you want to be sure that just because you never think that you're going to hit that number you are writing out there, just don't write something really, I guess, crazy, because, well, you might hit that for some time and you might get a surprising bill, I guess. All right, next is store procedures. Store procedures. So if we go back and revisit the physical partition, we have replica set, we have leader, and 3 followers. Store procedures are great for writing data because they always execute in the leader. They never execute in the follower. So if you are reading data in store procedure, you are really forcing your leader to read data, and that's really not a good idea. And if you want to use a store procedure, please just write the data, don't read the data. Next one is the user-defined functions. User-defined functions executes only in the follower. And if you are using them, just be sure before you develop it, you want to be sure that there's no system function out there. You're doing the same exact thing. The system functions are going to work much faster than whatever you're going to be able to write anyway. So use a system function rather than your own. And also, if you are using that UDF in your where clause, you want to be sure that you're using the partition key or something else in the where clause, because if you are going to pass the UDF in your where clause, then you are really going to force Cosmos DB to full scan your tables. So just be careful with it. They are great, but just be careful with them. And I believe that's all I have for you today. And thank you again. I can answer any of your questions now, or you can, reach me from the Twitter or LinkedIn. I will be more than happy to answer that from there.
Sounds cool. Thank you very much, Hasan. That was great. A lot of comprehensive stuff in there. I think a lot of people loved it. I don't see any questions in here, but let's get to our drawing here. So I've got my, there we go. Whoops. Oh no. Okay. This will work. Here we go. Let's do our first drawing here, and let's see who's a winner. If those of you who get picked up here, just hit me. Oh, it's Greg. Okay, well, I think Greg left, so I'll have to reach out to him. But if I pick your name, just DM me on Twitter at Mark J. Brown, and we can I can get your address and details and send you one lovely sticker and another lovely little coaster here. Okay, let's do one more. There we go. Yeah, that'd be funny if I hit my own. Oh, it was. Hold on. And then I had one spammer in there I had to block. I can't believe they're showing up. Let's do another one here. And it's the spammer. Okay, great. Let's try it one more time. If you block the person or whatever, that it would not show up in the drawing tool. It's a good piece of feedback for the StreamYard folks. There we are, Scott. You're the winner. Okay, so I hope you're still on. Just DM me on Twitter at Mark J. Brown, and then I'll reach out to you to get some details for you there. Okay, well, I think that's it. We're done for this month. We've got another one coming up next month. Oh, did I leave it up there? I didn't. Hold on. What do we got here? We've got already one set up for February. Looks like, yeah, querying JSON with the SQL API. Who's doing this one? Is it, I think it's Lenny maybe. No, Lenny was last month. Oh, no, it is. It's Lenny. So Lenny Lavelle will be back, and he's going to talk about SQL query. All the ins and outs about our flavor of SQL, which, unlike ANSI or T-SQL, is designed for JSON, which is why lots of people, including myself, struggle with authoring queries and trying to work with arrays and hierarchies and all that other stuff in there. So join us next month for that. Let's see, I see one more comment in here. Let's see if we've got a question. Joey here just saying thanks for the info, and David, thank you very much, and Tomash, good, yeah, and Sarah, she's out of here, and so is Greg. They're out of here too. So okay, that's it. Thank you everyone for joining us this month. I hope you enjoyed it. We're going to continue doing these, and so please spread the word. I want to grow our community of Azure Cosmos DB enthusiasts, and hope that myself and all the others who help contribute to presenting at these things can share helpful information to you to make your lives easier. So that's it. Thanks again, Hasan.
Yep,
and thank you everyone for joining us. We'll see you all next month.
Thank you.
Okay, bye-bye.
Bye.